K2-18b. The hidden ocean world. For as long as humanity has looked to the stars, one question has echoed through time. Are we truly alone in the universe? Across the dark canvas of the night sky, billions of suns shimmer like cosmic beacons, each surrounded by worlds we've only begun to imagine. For centuries, thinkers and dreamers have searched for signs of life beyond Earth. Now, for the first time in history, that search may be closing in on an answer. This new chapter begins with the James Webb Space Telescope, humanity's most advanced window into the cosmos. Unlike any instrument before it, Webb can capture light that has traveled for hundreds of millions of years, revealing details invisible to the human eye. When it turned its golden mirrors toward a distant star in the constellation Leo, it found something astonishing: a planet known as K2-18b, located about 120 light-years away. At first, it appeared to be just another exoplanet. But the more scientists studied it, the stranger it became. A world between worlds. K2-18b belongs to a mysterious class of planets called sub-Neptunes, worlds larger than Earth but smaller than Neptune. They have no counterparts in our solar system, making them incredibly difficult to understand. Orbiting a small red dwarf star, K2-18, this planet lies at just 0.18 astronomical units, less than half the distance between Mercury and our Sun. Yet, despite this proximity, it's not a scorched wasteland. That's because red dwarfs burn cooler and dimmer than our Sun, placing K2-18b right inside its habitable zone, the region where temperatures could allow liquid water to exist. And when the James Webb Telescope analyzed the planet's atmosphere, it made a discovery that sent ripples through the scientific community. Signs of water vapor, the most essential ingredient for life as we know it. The whisper of life. Water alone doesn't confirm life, but it's an important start. When Webb broke down the planet's light using its spectroscopic instruments, it detected something even more intriguing: methane and carbon dioxide, gases often linked with biological or geological activity. But buried within that data was a possible signal of something extraordinary: a molecule called dimethyl sulfide, or DMS. On Earth, DMS is produced only by living organisms, mainly tiny marine microbes drifting in the oceans. If confirmed, it would mark the first detection of a biosignature, a chemical trace of life, on a planet outside our solar system. While scientists caution that this signal still needs further study, the very possibility has made K2-18b one of the most promising candidates for alien life ever discovered. Part 2. Hycean worlds, oceans beneath the stars. To understand why K2-18b has captured so much attention, we must explore a bold new planetary idea: the concept of the Hycean world. In 2021, astrophysicist Niku Madhusudan proposed a revolutionary category of planets: worlds rich in hydrogen, cloaked in thick atmospheres, and covering vast global oceans beneath. The term Hycean blends hydrogen and ocean. These planets could be up to 10 times the mass of Earth and twice its radius. But unlike gas giants such as Jupiter, they may harbor deep, warm oceans protected by hydrogen-heavy skies, environments that could sustain microbial life even in extreme conditions. And K2. Why Hycean worlds matter. For generations, the search for life beyond Earth has centered around one simple idea: find another Earth. A rocky planet, the right distance from its star, with liquid water and a breathable atmosphere. But the universe, as it turns out, is far more imaginative than we are. Hycean worlds, a new class of planets, may change everything we thought we knew about habitability. They are larger than Earth, cloaked in thick hydrogen-rich atmospheres, and may hide global oceans beneath their cloudy skies. Their very size makes them easier to detect with current telescopes, yet their structure could sustain stable, life-supporting environments in conditions where Earth would freeze or burn. Their dense atmospheres trap heat like giant blankets, allowing liquid water to exist even at distances from their stars that would render an Earth-like planet solid ice. Some Hycean worlds might even remain habitable at temperatures reaching 200 degrees Celsius, 392 degrees Fahrenheit, conditions that would destroy most forms of life on Earth. And yet, we know that on our own planet, life finds a way. In the crushing darkness of Earth's ocean trenches, in boiling volcanic pools, and even within clouds of acid, microorganisms thrive where nothing else can. These extremophiles remind us that life does not always need a blue sky and mild sunlight. Sometimes, it only needs chemistry, energy, and time. If Hycean worlds share those ingredients, they may host ecosystems utterly alien to us. Organisms adapted to dense atmospheres, murky oceans, and faint red starlight. The discovery of such planets could multiply the number of potentially habitable worlds across the galaxy by hundreds, perhaps thousands of times. It expands the very definition of what a life-supporting planet might be. In other words, we may have been looking for the wrong kind of world all along. What Webb saw. The James Webb Space Telescope, JWST, was built to peer into the distant past, to see galaxies forming just after the Big Bang. But when it turned its golden mirrors toward K2-18b, it glimpsed something equally profound: the potential for life in the present. Using a method called transit spectroscopy, Webb observed K2-18b as it passed in front of its star. Each time this happened, a tiny fraction of starlight filtered through the planet's atmosphere before reaching the telescope's sensors. By splitting that light into a spectrum, a rainbow of wavelengths, scientists could identify which gases absorb specific colors. Each molecule, from water to methane to carbon dioxide, leaves a distinct chemical signature, like a fingerprint imprinted on the light itself. In just 2 observation sessions, each lasting about 5 hours, Webb's instruments detected water vapor, methane, carbon dioxide, and a possible trace of dimethyl sulfide, DMS, a molecule known on Earth to be produced only by living organisms, mostly oceanic microbes. If confirmed, it would be one of the most significant scientific discoveries in human history, the first indirect evidence of life beyond Earth. But even without certainty, the data painted a breathtaking picture. A vast, cloud-covered world, bathed in the dim crimson glow of a red dwarf, warmed by greenhouse gases, and wrapped in an atmosphere capable of nurturing chemical reactions essential for life. A world that may not just resemble Earth, but may, in its own way, be alive. What comes next exciting as these findings are, scientists approach them with careful skepticism. The detection of DMS remains tentative. Future observations must confirm whether it is truly there or the result of some unknown atmospheric process. Even the structure of K2-18b itself remains uncertain. Is it a water world with a deep ocean, or a mini-Neptune with a dense icy core surrounded by gas? How thick is its atmosphere? How high are its clouds? Does sunlight ever reach its lower layers, or is the entire planet shrouded in a perpetual haze? To answer these questions, astronomers plan further observations using JWST and future telescopes like LUVOIR and HABEX, which could analyze exoplanet atmospheres with even greater precision. Each new mission brings us closer to seeing these worlds not just as points of light, but as living systems with climates, chemistry, and maybe even biology. Yet one truth already stands clear. The discovery of K2-18b and the growing evidence for Hycean worlds have transformed our imagination of what life can be. It proves that habitability is not confined to Earth-like conditions. It may flourish in environments we once dismissed as too strange or too hostile. Life, it seems, might not be the exception in the cosmos.